Let's see. All right. Okay. Hopefully that's playing. Video capture device. That should be on. That should be on. Oh my God. Well, everybody, I'm trying to get this set up here. I'm not sure why the video's cutting out. Video capture device. Let's get rid of this. Let's go remove. Yes. Let's see. Well, hey everybody. Having trouble with the camera for some reason. Looks like it's not working. Let me try to see if I can fix it here, everybody. Video capture device. Microsoft Live Cam. Alright, so let's get rid of this other one. Oh, alright, fine. Let's get rid of that one too. Let's go add video capture, create new. This is gonna be live cam. Okay. Let's do okay. Well, I'm not sure why it's all blurry. We're really kind of flaking out at the moment. I apologize for that. Not sure. Okay. Let's see. That's on. Sorry, everybody. I'm just trying to get this this thing to not shrink my head too much and not get in the way too much. So sorry about that. Just bear with me a second here. Transform, edit, 50. There we go. All right, hopefully that doesn't take up too much screen real estate and everybody can still see the screen. I don't know if it's gonna let me move it because I've got my Mastercam on the other side. So what I'll do here is I'll just reposition it just a little bit. Back into focus. It's being a little weird on the focus. Let me see if I can. Properties. Deactivate and activate seems to be the trick. Okay. So, got some people. Hey Colin. Hey guys. Hey Tom. Yes, I did get a haircut. Funny enough, I gave it to myself, believe it or not. So this is, my own work here. I must say it was a challenge, but I was up to it. It happened to be Easter when I really needed a haircut, and being Easter Sunday, most places were closed, so I had to improvise. So we had a question about couple of questions. How to move parts in 3D. How to work with edges. And that really kind of comes back to geometry itself. How do we work with and edit and create 2D geometry, which then is used to derive 3D geometry. We've got some good examples on this part itself. So this is the part we're looking at, kind of a thermoformed part that we want to cut out. And we need to be able to orient this in 3D space. So what I like to tell people is we're trying to match up what happens in the real world with the computer graphics that are being generated in the software we're working in this case Mastercam. Hold on a second. Sorry, little background noise. My daughter and wife are downstairs, so I wanted to close that door. And what we've got is this 3D geometry that at its heart was created from 2D geometry originally. So the heart of a 3D model like this model that we're looking at here, and in this case I've got both the as and the opposite shown. So why don't we take a look at our levels. I think the last time we were looking, we basically oriented this part in 3D space, and we'll talk about that again and how do we reorient the geometry. And then we mirrored it as well to get this other copy. So you'll notice I can turn on and turn off the piece of geometry on the left here. And I'm doing that through using Mastercam's levels. So we've got these, what in computer parlance is known as a function panel. So if I left click and hold on the word levels, you'll notice I'm dragging this panel out. And right now, down along the bottom of that panel, I'm kind of covering it with my mouse, there's a series of tabs. So we have toolpaths, we have solids, we have planes, we have levels, we have recent functions. All of these are, let me see if I can get that to go away there. There we go. So all of these are, sorry, I keep going down to my Windows taskbar and it's popping those up. I'm trying to avoid that. Let me resize this. There we go. Now they won't get in the way. So I've just undocked this function panel. I left clicked and held down on it and I dragged it. And if I left click and hold again, what you'll notice, there are some docking points that come up on the screen. So are some kind of quick reference options here for basically upper, top of the screen, left of the screen, bottom, right? So that's in the very center. And I've got that same functionality that appears to the very left, very bottom, very right. So I can dock, there we go. So I can dock this function panel, or in this case, I can undock it and I can leave it floating. Now, the actual number of functions that are displayed are controlled on the View tab. So if I go up to the View tab here and click on View, you'll notice in this little Managers section, I've got toolpaths, solids, planes, levels, and recent functions turned on. So if I turn these off, for example, I can hide some of those function panels. So in this case, I've got everything turned off except for planes. Now, I normally wouldn't want to do that. Normally, I'd want to leave most of those function panels active and just tab through them on the bottom of the interface. So if you find that you've accidentally turned a panel off, so for example, the levels function panel is actually, there's a toggle on the keyboard, Alt-Z. So if I hold down the Alt key and press Z, you'll notice that it actually turns on levels. It actually enabled that function panel, and you'll notice it's lit up here in the manager. So I can turn these on and turn them off. Like I said, normally I just leave them all on. Groups is not a function panel. Groups is actually the group manager. And normally the only time we see groups being created is when we are translating geometry. So translate is kind of Mastercam's word for a combination of move or rotate. Oh, sorry guys. I think got a little pausing going on there for a second. So, where was I going? For groups, normally the only time we see groups is when we're doing translate function. So if we're copying or moving geometry, you're going to get colors that appear. Red being the group function and purple being the result function. So whether you are moving, copying, or rotating geometry, the results of that transform operation get added to the group manager. The other time that we see groups come into play is if we are merging geometry. So if you merge in something from another file, a vise or something like that, there will be new groups that are added to the groups manager. And I bring that up because sometimes it's easy to get carried away by importing all of these fixture items that end up really bringing your Mastercam file to a crawl. So if you're bringing in every single tool holder and every single bolt, nut, and screw of a complicated fixture, sometimes that can really have detrimental performance effects. So we have to be a little bit careful of that. So normally I use or I leave all these function panels turned on. There's one more function up here under managers, and that's multi-threading. So if I click on multi-threading, you'll notice it brings up a separate dialog box. This is the multi-threading manager. This is used for controlling toolpaths that are multi-threaded. So most of the newer style toolpaths have advantages to being run in a multi-threaded state, and you can control your multi-threads in here. So for example, I don't have any toolpaths that are currently generating. If I did, this button, this little settings button, would not be available. Because I don't have any generating currently, I now have access to the settings and I can click on it. And so now it tells me maximum number of threads. So the maximum number I've got set to generate at any one time is 2. And the default thread priority typically is normal, but in this box it allows you to control it. So I like to set my default thread priority to high, which really depends on the type of thread that's being run, because there are different types inside Mastercam based on the individual toolpath that's running, as to whether you get much of a performance boost here, but you certainly have access to the settings in the multi-threading manager. Now, most of the older style toolpaths are still single-threaded paths. So if you're using a lot of just regular parallel or flow line, or some of the surface finish contour, some of the older ones, you're still going to be slightly limited, thread locked, thread limited in the fact that you can't run some of those processes concurrently. You have to run them sequentially, unfortunately. So there are some limitations there. So I'm going to go ahead and close the multi-threading manager. For my function panel, most of the time I'm jumping back and forth between a combination of toolpaths, solids, planes, and levels. So these are the ones I use most often. And levels, especially in combination with the planes, is something that I use to organize my geometry. So something that comes up as a programmer quite a bit, especially if you're working with other programmers in a group, is the need to organize and label your geometry, your operations, and in some cases the groups within the toolpaths manager. And this just makes it easier for you to understand what you've got in your file, and when you get to your NC code, where a certain section of NC code is being generated, if you put in a comment, it's a lot easier to tie it back to the specific spot within the Mastercam file that actually generated that NC output. So it's just a good practice to do that. In this case, I'm going to go ahead and dock that function panel. So I'm going to left click and hold on the word levels up here, the title bar, and grab a hold of it. I'll put my cursor on this little docking icon that comes up and let go. And now you'll notice I've got my levels manager and it's docked in here. And so the way a lot of these function panels work, you've got a series of commands or options or functions that are available in the top. So for example, I can add a new level here. You've got find a level from geometry, which will allow me to go to the graphics window over here and select something and it will then highlight the level that it's on. We have some options for turn all levels on and turn all levels off. And what these commands control is level visibility. So in the function panel right now, I'll go ahead and just create a new level. In this case, I'm going to go down to the level number, highlight 15, and I'll just type in 40. And that's going to be level number 40, and I'll press tab, and you'll notice what happens. It puts my cursor down into the name box, so it automatically kind of prompts you to name the level. What are you going to put here? And in this case, I'll type in points. We'll call this transition points. And we'll say this is for the point toolpath geometry. And so what I want to do in this case is I want to select these points and I want to move them to this new level. And you'll notice when I look in my levels manager, I'm going to go ahead and widen this just a little bit. So this ends up being a series of rows and columns, kind of similar to Excel, if you've ever used that for like a spreadsheet for entering geometry or for entering data. In this case, it is just a spreadsheet that tells us information about what we've put on the level based on our naming convention, and then what kind of geometry is on that level. In the settings or display options here, I'm going to click on this, and I'm going to turn on contrast rows. So with the contrast row setting turned on, you'll notice that it made some of those rows gray to kind of help differentiate and help you just better visually see what's on, or the separation between each level. I'll say it that way. Hey guys, looks like Zeke managed to join in. Good to see you guys. So we're talking about the levels manager. I've got the contrast rows turned on. One of the things you'll notice is when I created this new level, it automatically became the main level. And the main level has got this little green checkbox right here, this little green check mark. So the green check mark indicates which level is set as the main level. And there's a setting in here that basically it says active level is always visible. So whichever is the main or the active level, that you're not accidentally creating geometry on a level that is invisible. So because we can move geometry between levels, it allows us to organize our file better. So in this case, I want to select those 4 points and I want to move them to level 40. Now, there are multiple ways to do this. I'll show you the way that I like typically to move geometry. I like to pre-select my geometry before I go into the function. So I'm going to left click and hold, and as I continue to hold my left mouse button down, I'm going to drag it to the right and down. And what happens is Mastercam starts to generate a selection window. And anything that is inside that window, kind of contained within the perimeter of the window itself, like imagine the square that you see for my webcam, right? Everything that's inside that window is being displayed. Everything that's outside that window is being cropped out. Well, this is the same kind of idea. I'm selecting geometry inside the window, and I can actually control whether that geometry selection window is only inside. So in other words, if I drag a window out, you notice my window right now is partially selecting that solid, but it is not fully selecting that solid. So if I click to stop that selection window, you'll notice that solid did not get selected because it was not fully inside the selection window. That's an important distinction. Oh. Looks like my sorry guys, a little technical difficulty. Pretty much my webcam is being junky and cutting out, so sorry about that. But I was talking about selection. So with the selection window that comes up, the default is it only selects what's inside the selection window. There is the ability to control that selection right here. So if I click on this little drop down, you'll notice we get options for our selection mode. So fully inside, fully outside, inside plus intersection, outside plus intersection, or only intersection. So those are the selection window configuration options. So we can configure that selection window. The default is fully inside. And this is what we call kind of normal selection mode. Normal selection mode is I can click on something to select it. I can click again to deselect it. So you'll notice I can deselect all 4 points. Right now I have nothing selected, no geometry. I can also press the escape key, the ESC key on the keyboard. So if I click on one of these points here and I decide I don't want it selected, I can then press the escape key to deselect it. Let's see. I was told to not move the solid models in Mastercam. That will cause error in the geometry model. Is this true? I don't think so. So some people have requirements for their business that they maintain the model coordinate system that the geometry comes in at. Now, the quality of the model that you get in automatically kind of sets up how good the model quality is. So it's either a good quality model, meaning it has tight edges that fully meet where there's no gaps, or it's a poorly done model where there is at least one or more gaps. You have some tools for analyzing the initial model when it comes in. So let's do this. I'm going to save this. Open. Okay, at least this doesn't have anything on it. So what I'll do is by the way, everybody, if I seem a little loopy, I just got my COVID vaccine shot. I just got my first Moderna shot. So I am feeling a little kind of under the weather, so just a heads up. So if I start like not making any sense, let me know by all means, because I feel okay, but I still kind of feel a little loopy. So I just want to give everybody heads up. It's the vaccine. I haven't been drinking, none of that stuff. So so we've got a model. We just brought it in. Could have come from anywhere. And what I'll do is I'll give you what we kind of normally get. Okay, so I just moved the model to some random coordinate, and I ran basically no history on the model. Now, if I unzoom a little bit, and I'm doing all this graphics manipulation, by the way, just using my mouse. So I'm using my mouse. When I get over the top of the model, I center click and hold on my scroll wheel, and by doing that I can go into rotation mode and I can keep the model kind of centered on the screen. If you're not clicking and holding with your cursor over the model and your part's way out in space, so your part's, you're out here and your part's out here, and all of a sudden you try to rotate and it just flies off the screen. Well, if you have your cursor over the top of the model and then you center click and hold, you'll have a rotation point that's actually locked on the model itself. So I'm manipulating the model by center clicking and holding, and then zooming in and out is also accomplished with that scroll wheel. So I'm just rolling the scroll wheel forwards or backwards to zoom in and out of the model. So just a heads up on that. So there's kind of two camps. People that program aerospace parts typically get the part coming in aerospace coordinates. Now what that means is that for, say, a part from Boeing, that you get a piece for the wing. You get some rib or some station or some part that comes in, and it comes in what they call airplane coordinates. And so there are terms in the manufacturing world for manufacturing aircraft, like waterline. Well, what is the waterline? The waterline is the place where the plane would basically float in the water, before it started leaking and water started rushing in. It's kind of the buoyancy point, what you could think of as the Z plane, in the XYZ coordinate system. Everything that's at Z0 is at the water line in the plane. So when, in terms of doing kind of aerospace parts, there can be some advantages to not moving the part. I don't think it has any bearing on the quality of the geometry. So I want to make that distinction. That the quality of the geometry that you import is not dependent on its position in space. Its position in space is independent of the quality of the geometry. Normally the quality of the geometry is dependent on the export tolerance that the guy who exported the model used from that CAD software. And by the way, Mastercam, if you didn't know, if I go up to the file menu and do file open, and I just go browse, and I click on the file handler here. Sorry guys, hold on. Okay. So this this little drop down box here is what's known as the file handler, and it selects the file types that Mastercam has available to open. So there we go. Okay. So if I click down in the drop down, you notice we have Mastercam files, anything with .mcam. We have Mastercam X files, so these are the older style, anything with a .mcx, MCX-4, -5, -6, -7 for -9 for some of the older versions of Mastercam X. Then we get down to some of the other file import options like IGES, but you notice we've got AutoCAD types, DWG, DXF, we've got parasolids, so X_T, X_B. But I tell people, if you're getting a parasolid, do they just have SolidWorks? Because if they just have SolidWorks, Mastercam directly imports the SolidWorks file type. So depends on their SolidWorks version, your Mastercam version. Are you up to date? Are they up to date? So there can be some of those import issues. But even things like CATIA files, you actually have to pay for an extra upgraded translator to be able to bring in native CATIA geometry. I think the same thing for I want to say NX. So if you want to import native part files, they have an NX native translator. It's a little more money, but there can be some significant advantages to buying one of these translator packages that allows you to import the native file. And the advantage is higher quality geometry. If you get the native geometry, often you can, for example, bring in the native CATIA file and be able to turn on and turn off some features in the file that may be hidden that you didn't have access to without the translator. If you're at the mercy of some engineer who has been tasked with exporting a model for you to use, and you don't necessarily know what options he has available to control, a lot of times you just get the default. And when you get the default, sometimes that can be a pretty wide open tolerance. And so if the guy exporting the model has a default inch export tolerance of 0.1 millimeters, well, that's 4/10. If it's 0.1 millimeters, that's 4 thou. So it's pretty easy to get bad geometry through kind of no fault of anyone's. It's not like the guy did it to you on purpose. He just didn't know what you needed. Nobody really told him, here's where this magical setting is that controls the output. But the other thing is, you also need to be able to know how to work with geometry in Mastercam, because there are options that allow you to rebuild stuff, build new surfaces, build splines, fix splines, and you need to be able to do that sometimes in order to just work with what you're given. So for example, we've got this part here, it's got a hole in it, and if all we care about is trimming it, we probably don't need to fix that hole in order to actually trim the features that are in the geometry that we've been given. We can cut the part without fixing the model, but it's nice to be able to know how to fix the model when you want to or need to. So we can take a look at some of that stuff as well. Okay, so my point here with the file handlers is Mastercam has a ton of built-in options for importing files. So if you're getting something like a crappy IGES file that just is surfaces and just kind of ugly and doesn't come in very well, Ask them if they can do step. So step is the kind of evolved ISO standard modeling language, and it's a better standard than it's IGES, but we have fun with the name when we call it IGES, because the types of geometry that are supported just aren't as good as some of the new solid modeling kernels like step, like Parasolid, like Dassault, and their modeling kernel, all that stuff. So Mastercam has the ability to import a lot of different stuff, so take advantage of it. Work with the other engineers to make sure that they're exporting quality data for you to work with. So we've got this part. I've moved it around, and one of the other things that's going on right now, we've got our WCS set to the front plane. So in Mastercam, we have kind of a bunch of default planes: top, front, right, left, back, bottom, isometric. And those default planes, we can use them, but I prefer not to. So I prefer to generate my own new planes for my top WCS and then any new WCS that I might create. And I create my own new planes because one of the things you'll notice about the system views, so if I go to top, front, back, any of these guys here, the origin is locked out. So this option down here to actually move the plane doesn't exist if you're using one of the default planes as your first operation. So what that means is that if you've programmed a part and there's something wrong with the origin and you need to actually move the origin in your toolpath, in your program, you can't do it if you've used one of these default planes. You have to do it by actually moving the geometry. No, it's not a dumb question at all, Tom. So planes in Mastercam you can think of as a couple of things. So we have a default Cartesian coordinate system. So we have a series of X, Y, Z axes that are at right angles to each other. And they are built in what they call the world coordinate system. So Mastercam just has a default origin, some point out in space, which is 0, 0, 0 for X, Y, and Z. On your machine has a set of X, Y, and Z axes. And those X, Y, Z axes are arranged at right angles to each other. And when you go out to the machine, you're going to set a work offset. And that work offset is the 0 point from where your program coordinates come from. Well, in Mastercam, your geometry is relative to a 0 point. And that's all it is. So planes are derived from the geometry itself that you're bringing in if you're not going to move the geometry, which is an option. And the problem is there's 10 different ways to do everything. What's right? Which is the right way to do it? The right way to do it is the way that works for you. It's the way that works with your machine and your shop and your shop's requirements, right? Because like I said, I've seen 10 different ways to do everything. At Boeing with our machines, we did not use a work offset. We didn't use G54, G55, G56. We didn't do that because the way they had set up the machine was to use what they call a local work offset, G92. Because we had such long beds, we had 420-inch long beds in X. So it's a big fixed bed gantry router, and the guy could be anywhere in space. We didn't know where he was going to be. So the work offset really doesn't matter in this case. It's the machine position. So what we do is we put the fixture on a pin. We know where all the pins are. Pins are every 10 inches. X10, X20, X30, X40, X50, there's a pin, right? And so we drive to a certain pin and we'd say, okay, this is the program 0 point. We're 3 inches above 0, go. And because all the geometry is relative to an origin, everything just worked. Well, that's no different than using a work offset on the machine. In Mastercam, the origin of the plane is the origin of your work offset on the machine. So that's the way you got to think about it, the way that your setup works. And that's the same whether we're doing one setup per part, which is what you got. Basically, you've got one big fixture, you got one work offset, you're going to set a 0 point, and the cutting is going to happen relative to that XYZ position. In Mastercam, there's a couple of ways to work with that. You can leave the origin where it is, and you can move the geometry. You can also leave the geometry where it is, and you can move the origin, which is super confusing to a beginner, but it makes all the sense in the world to the experts because they need to be able to move stuff around and they need flexibility. So flexibility is what you get with Mastercam. It's like a big Swiss Army knife, which is not meant to be insulting. It's just meant to say that, you know, you've got dozens of tools that do similar things that work in similar ways, and it's kind of sometimes it's like, well, which one do you use? Well, which one do you prefer to use? Because they all kind of will get you to the end result, which is I've got my geometry relative to my 0 point, like my stock or material is relative to my origin, my G54 0 point on the machine. So I'm going to go set my XYZ 0 relative to some block of stock. I'm going to move my geometry relative to some origin so that I can get it into position. So, when people are saying that you shouldn't move the geometry, unless there's some reason for that, like you shouldn't move the geometry because we do things like X, Y, and Z. We create a local origin point and a local axis coordinate system on the part, and then we program from that 0 point, and we do that because we need to be able to bring in the part for revisions quickly. Then I agree. I think you shouldn't move the part. I think you should create an axis coordinate system out in space. I also think doing that, if you're not used to it, is confusing. John also brings up a good point. What about WCS versus tool and construction planes in respect to the multi-axis toolpaths? This is really a post-processor dependent answer. So if you are working with a modern day post supplier like in-house solutions or Postability or CNC software or any number of good guys out there, and they have written a post that takes advantage of the WCS, no problem. If you're using an older version of the generic Fanuc 5X mill post, I recommend you take your part from wherever it's sitting in 3D space. First of all, make a copy. There's no reason not to have multiple copies of the part in the file unless it's a super giant multi-megabyte part that weighs you down. What I typically do if I get a part that's out in space, it's out in like aircraft coordinates or boat coordinates or name a coordinate system, SolidWorks, because they use front instead of top. Why? I don't know. I don't care. I move the geometry. And this is just personal preference. It's just what I like to do. You know, I like to tell people it's how I was raised. You know, it's not my fault. But, you know, I started using posts when they didn't really support WCS, or you could say it like this: they kind of supported WCS and there were bugs. And because there were bugs, it made all the sense in the world to take your geometry, move it back to whatever origin you wanted to work from, so you knew what to expect. Now, the other thing about Mastercam is very geometry centric. Okay, it is geometry out in space. It is a toolpath, which is either based on a plane or based on tool positions, which are vectors out in space. That's it. It's real simple. So it's either some XY coordinate system, which also has a Z automatically, because if you've defined XY, you've automatically got Z defined in there somewhere, at least mathematically speaking. If you've got two mutually opposed vectors in space, you can generate a third one that is mutually perpendicular mathematically. You just use the Euler formula and boom, you got it. So you have these planes that are out in space, and they're you can rotate them to any angle, and that's what the planes manager gives you. So the other thing, Tom, is we're talking about planes like top, front, right, left, and these are all mutually perpendicular right angle planes. There's nothing that says a plane has to be at a right angle. And in fact, if we look at this part, what you're going to see is, if we look in terms of an XYZ world where we've got mutually perpendicular planes, you've probably got some surfaces on here that are parallel to the top, front, or right side in 3D space if we move the model. But then there are other features that are non-planar. They don't line up with top, front, right, left, any of the default planes that exist. So what Mastercam allows you to do is create a new plane with any orientation in 3D space. And we do that internally, mathematically, with a matrix. So a matrix is, in terms of creating a coordinate system, a matrix is 9 variables. There's 3 variables for the X vector, there's 3 variables for the Y vector, 3 variables for the Z vector. So by using these 9 coordinate positions, pure mathematics, there's nothing physical about it until we get out to the machine. But using pure mathematics, we can define a coordinate system in 3D space. And so that's what we do. We define what's called a tool plane matrix. And internally inside the post takes a look at where our plane, how our plane is oriented in relationship to our WCS matrix. So there's a couple different matrices involved. We use vector and matrix math in the post to resolve the rotary angles and figure out if I'm tipping my head, in your case, or if I'm rotating my part on the table, in another case, right? Mastercam doesn't really know anything unless you get into like the mill turn side with a 3D machine environment. Mastercam doesn't know anything about your machine. It knows about your part geometry, and it knows about your tool and how you want to move that tool in 3D space. And through the post processor that links the work you do here to the real world, you can get 5-axis output, you can get 3-axis output, you can get 2-axis, you can get 6-axis in the case of like a robot or something like that. So the plane creation is only really needed when you need to cut features. Like in a 5-axis world, if we have to cut a feature that doesn't lie in the top or the front plane, we either need to use a 5-axis toolpath like Curve 5-axis, or we need to create a tool plane, tool and construction plane in this case, that is kind of in relationship to the feature that we're going to cut. But in general, you're always going to have some kind of WCS, whether it's using the system WCS or creating your own. That WCS is, how does my part sit in the real world on my machine? That's what the WCS represents. And when you have a WCS that doesn't move, and then you move the tool plane in relationship to that WCS, the post uses that as a trigger to say, oh, the plane has changed. If the plane has changed, then we need to recalculate the z-axis coordinate position of the tool plane in relationship to the XYZ matrix of the WCS. And we need to see, is that coordinate different from the last coordinate? Because it may or it may not be. One of the things you have to keep in mind is that with Mastercam, the operations themselves may have multiple tool changes inside the operation. So for example, contour toolpath. If you had depth cuts or if you had multi-passes, each one of those passes is what they call a null tool change operation in the post. So the post has to do all this work to interpret and say, do I need to cancel my high-speed modes? Do I need to re-output my tool change? What do I need to output? Because I need to compare the last rotary position I was at to the current rotary position I'm now at, and I may need to output a whole new tool change with a whole new, BC or AC or whatever position, or I may not. I may, maybe it's just the same operation, right? I just picked up and I just did one cut. Now I'm going to reposition my tool and I'm going to make the next cut, and then I'm going to reposition my tool again and make another cut, but it's all part of the same op. So I don't want to change rotations. I just want to move the tool tip in XYZ, if you will, but without rotating AC or BC or any of that. So we've got this geometry. We just brought it in. I'm going to go ahead and make the top plane the active WCS. So I'll select it and I'll press the equals button. And then I'll look at this in the top view. Sorry, I'm just going to change the appearance real quick. So one of the things I like to do when I'm manipulating geometry, colors, levels, I like to select it and then right click, because I get this menu that pops up. So for example, I'm going to choose this kind of orangish color, make it a little easier to see. So we want to move this thing in 3D and position it. So let's actually do something before we do that. Let's look at building a little piece of tooling, because I think it'll help in some ways. So I'll go to levels here. Geometry test. I'm going to create a new level. Let's call this fixture build. And what I'm going to do here, I'm going to go into my surfaces menu. And I'll do a surface from solid. And I'm going to triple click the model. By triple clicking, I get it to select all the faces of the entire solid. And I'm going to go ahead and turn that solid off. And part of the reason I want the surface is I'm going to go to my View tab, and I'm going to make sure that backside is turned on. And what the backside allows you to do, if I grab just a couple of surfaces, I'm going to grab these, say, 4 surfaces right here. I'm going to select them. And then I'll do Alt-E on the keyboard. So that's Alt-E, Alt-Echo, so the E key. And by selecting those 4 and then pressing Alt-E, I've temporarily hidden all of that geometry. So I've only got these 4 surfaces displayed in Mastercam. Everything else is temporarily hidden. And I'm doing that to show you the back side of the surface. So with backside turned on, the front side of the surface is whatever color the surface is. If I change this color to, say, blue, you can see the surface is blue. It looks good. If I look at the backside is all this kind of olive color. And so the backside of the surface is, when it's a surface, not a solid or solid face, when it's a surface, you can actually see where the backside of the model is. So I'll do Alt-E to bring everything back. And what I'm going to start to do here is look at, or select all of these surfaces that are on the underside. So this is the kind of the surface where the part itself would rest on top of a fixture. So if we put this thing on a fixture, all of these faces that are on the back side, on the inside of this part, are going to be what basically are resting on our fixture. So I'm going through and I'm selecting all these faces, and I'm being careful to make sure that I get them all, because it's real easy as you're selecting multiple surfaces like this. It's real easy to accidentally not select something. And so what I'll do, just to demonstrate, I've selected part of it. I haven't selected all of it, but I'm just going to right click, and I'm going to go to my surface colors here, and let's use this green color. So I'll use this bright green. So you can see that what I've done is I'm only, if I'm on the outside here, oh look, when I brought it in this time, there's a lot of surfaces where they're actually reversed. So we have probably some problems, some issues with the solid in that area. I can just tell that based on the fact that it's reversed some of these guys. So we'll have to look at that later on the solid. But what I'm going to do is continue to select all these surfaces on the inside here. Like I said, I don't want to accidentally forget anything. And there are some areas you can see where I've got these little tiny slivers of a surface. So I have to be real careful not to accidentally leave something behind and not get it selected. Yeah, so Tom's asking, when you say reversed, you mean the normals are reversed. That's correct. Because keep in mind, right now I'm dealing only with surfaces. These are not solids or solid faces. They're separate entities. Each piece on here is a separate surface. They are not connected physically in any way. Each one mathematically is basically, it's a patch, and then there are boundaries on that patch that describe the exact extents mathematically of that surface. A solid is a connected, meshed together body. So there's a lot more that ties everything together when it's a solid. So part of the reason I'm working with this, I didn't want to do that, but part of the reason I'm working with this as surfaces, I want to be able to just look at these backside surfaces that are going to be the actual faces that touch my fixture. And it's hard to look at only the faces that touch your fixture when you've got other geometry in the way. So I'm going to change the color. I'm going to move them and put them on a different level so that I can look at just that shell of surfaces and I can manipulate them if I need to. So I've got that stuff selected. So you'll notice that's basically just 1/2 of the surfaces on the inside. Now there are some tools for selection that I could potentially be using here to try and basically select things that are tangent, but some of that functionality I find is only really effective when you're doing selections for tool pathing. So here I'm just essentially manually doing it. I'm just walking around picking all of these inside surfaces and trying to make sure that I don't miss anything. And you'll see, for example, here's an area on the model where there's a hole. So there's a surface here, but because there was a hole in my solid, there's a hole in the surface. So that's an area that I would go with my surface tools in Mastercam and fix. And I would maybe fix it on the part that I was going to cut, but I would for sure fix it on the model if I was trying to build, like a solid fixture, because I would probably want to make sure that my fixture was a watertight solid. We'll talk about that in a second. So I am walking around. I'm actually, because I've done a lot of work in selecting, I want to make sure I don't mess it up. I'm just going to go change those colors. So, almost done. There's still definitely a few surfaces here, but we're almost done. So, get these last couple. All right, we want to make sure we get all of them. We don't leave any of these guys behind, because again, when we're building something like a fixture, it's best if we can start out with something that's watertight, at least as watertight as we can get it. All right, so that should be kind of the last, if we got them all. And so now we can do some examination, just kind of zoom in, rotate, make sure we got everything. And it looks like we're pretty good. The place where we'll really see it is when we hide everything else. So keep in mind, I have not let's see, they need a magic wand tool where if it's running, whenever you hover, get selected. I know it'd be nice to be able to, to easily, there are some other selection tools that we can get into using. There's like vector selection. You can stretch a line across the screen and it'll select anything that touches it. There's some other stuff, but be that as it may, once you have selected something and changed the color, for example, I can now select it by color. So on the right hand side of the screen, I think I might have talked about this a little bit last time, we've got these quick mask selection bars. So for example, I can select all points or all lines or all circles or all splines. In this case, I can also go down and choose all color or only color. So if I choose all color, I can go, for example, and choose all of my green, number 10, select it and say OK, and I've just selected everything that's green. So now I'm going to right click and I'll choose this option here in the little attributes bar for change level. So I've selected all of green. I'm going to choose change level and I'm going to choose to move it. And we'll go to level 40. And I'll call this inner surfaces. And now, because I've hidden or moved all of those inner surfaces, I can now look at the outer surfaces. So I'm looking from the back side through the model. Remember, all the space inside the model, when it's a set of surfaces, is just empty. So now I'm looking through the model. You can see how thick it was here. So that's the thickness, because that's the inside of one of the slots. And you can see here's a surface that didn't make it. So there's probably some issue. Yeah, you can see that modeling wise there was some kind of error. And I can tell there was an error because there's this weird little kind of stripped surface. Now, here's an interesting case. I want to be able to manipulate my screen geometry. I want to be able to rotate it around using an anchor point. And one of the advantages of having a solid is at every face, at every edge, you've got a vertex that you can just select and you can just rotate with it. With a surface, you don't necessarily have the same type of selectability that a solid has. So for example, if I want to rotate around so I can look at this a little bit more easily, I may want to grab kind of an endpoint here. Now, normally you'd have to actually physically create wireframe geometry on the edge of that surface before you rotate it around. But there's a secret. So if I just go here and right click and I choose dynamic rotation, Mastercam's going to prompt me with the screen prompt. It says pick a point to begin dynamics. So I changed the background here just to make it a little more obvious, so everybody can kind of see it a little. It says pick a point to begin dynamics. This little drop down here, hold on. Okay. This little drop down here is called the auto cursor. The auto cursor allows you to select different points off the model. Some of those points will auto-select by default if you just hover your cursor over them. But in this case, what we want to do is select the end point of a surface. So I'm going to choose end point. Now you notice if I drop down over here, that little endpoint icon highlights on the surface. So this is the endpoint of the surface, not any kind of wireframe geometry. And I just want to show you that I could select the endpoint of a surface as an actual selection here. So this piece of surface here kind of highlights what some of the problem is. There's some weird, when this model imported, there was an error. There was a hole in the model, and it's resulted in this little tiny sliver of a surface being generated. So when we created the surface, you'll notice if I do some selection, they're actually, this is a surface here, this little weird edge, and this is a surface here. So I'm going to go ahead and delete those. And I'm going to delete them because I can't really do anything with them. They're kind of just holes. There's another one here. And I can also see them if I unshade. So when I unshade here, you'll notice if I zoom in, it's just this weird little shell edge shape of the surface. So that when I have this in an unshaded mode and you're looking at the surface ISO lines that are running up and down, the UV lines, that's the other reason I like to go with surfaces. Sometimes when you're looking at solids, it can be a little hard to kind of detect what the error is. So I'm going to get rid of these little weird pieces of shell surface. Ooh. So, yeah, you can see them. That makes it real easy to see. So, I'm going to grab that little weird piece there, that little weird piece here. So, now that we've gotten down and we've kind of reduced this to the outer shell, let me set that back to being orange. I'm going to go ahead and save that. We've got a good outer shell, except for these areas where there are holes. So what can we do about that? Well, we could go ahead and try to fix where these little fillet areas didn't quite fill in accurately. And the way that we do that is first we generate some wireframe. So I'm going to create a new level. Call this surface patch geometry. Call this outside. And for wireframe color, we'll go with blue. And I'll also make sure that we're in 3D mode. So I'm going to do a curve one edge. The first thing I'm going to do is click on the edge of this little fillet. So I'll click on the surface, I'll drag to my edge here, and I'll click to place it. And if I unshade, one of the things I'll try to do is turn on this fit lines and arcs. On the home page, I'm going to make sure my arc center point is turned on, because I want to see if this is actually generating an arc or if it's generating a spline. And it looks like it's generating a spline. Let's go. Nope, center point's turned on. So that's okay. I'm going to go curve one edge. So I tried to do curve one edge here, and because it's this big flat surface, you notice it didn't break this edge right here. So I've got a piece right here, I've got another piece right here. Some of that has to do with this break angle. So if I set this to 10 degrees, let's set it to 1 degree. There you go. So that's 1 degree break angle. I chose right here. It tried to break it. I'm only getting a little piece. So I'll try 2 degrees. I'll try 5. See what 5 gives me. How about 15? No. So, at some point here, I go from getting the whole thing to getting a little tiny piece. So if I try 8, no. So we'll just leave it. So I'll just take the whole thing. So even though I've got this piece here, this, all this, the rest of the geometry, I was really only interested in these parts right here. Okay. Down here, I'll do create curve one edge. I'm going to grab that edge there. You notice I got this orange point, so I actually got an arc, which is good. I got another arc over here. All right, we're in business. We're getting some arcs, so that's good. Now over here, I want to generate this surface, but I've got these extra pieces. So like over here, the spline that was generated has a bunch of points. It goes all the way down this edge, and I really want it to end right here. So what I'm going to do is I'm going to take this guy and I'm going to break it, and I'm going to use the end point of my existing arc right here in order to do that. First I'll save it. Then I'm going to go to break 2 pieces. I'm going to break that spline. It says indicate the break position, and I'll choose the end point right here. So I've now broken that spline so I can use it to generate my surface. I'm going to do the same thing. Oh, but I need a piece to break with. So I'm going to do curve one edge. And I'm going to generate the wireframe I need over here. Well, let's go 30. So we'll get those pieces there. And we might as well, while we're at it, fix these guys. So I'm creating this extra wireframe on the areas where we are missing the surfaces that should have been here from the solid, but we're going to fix it. So I've created this extra wireframe, but there are still some areas like here that need to be broken. That needs to be broken. That's fine. That needs to be broken. That one. That one. Okay. So I'll do Alt-E. Break 2 pieces. Break that guy. Break that one. Break it there. Break it. Break it. Right. So now I'm in a situation where I want to get rid of some of these pieces of wireframe, but I don't accidentally want to delete my surface. So what I'll do here is I'll go to my little quick masks over on the right, and I'm going to choose the option for select only wireframe entities. So it's only going to let me select wireframe. So I'll turn that on. And now I can go kind of in between I don't necessarily need to do this. Delete these extra pieces here, but it's just going to help me when I go to do my selections for building my surfaces. So I'll go ahead and save that. So the last thing, I've got some areas here. So like this guy right here, that really should be one entity when I go to chain it. Got a question. Do you have a favorite third-party program for fixing holes in solids? Space Claim's a pretty good one. I've used it kind of briefly. We have a license of it at work, so it's not something I get to play around with a lot, but it seems to have some pretty good tools. So I would say if you're having problems with geometry that's coming in, I would definitely look at Space Claim because it seems to be the best at repairing stuff that's out there. For pure surface modeling, if you're just working with surfaces, Rhino is really hard to beat. It used to only be $1,000, like $9.99, so it was pretty affordable even for just most people. Rhino was pretty killer. So what I want to do is I want to clean this up, right? I've got 3 different entities here, here, and here that I really want to turn into a single spline. And I got the same thing over here. So what I'm going to do is go to my curves area here, or my splines, and I'm going to choose spline from curves. So create a spline based on geometry of existing curves. And so here I'm going to go into partial mode, and I'm going to click on the first entity and then the last entity. And now it says select the first entity to start a new chain or modify the active chain. So I'll start one here and I'll end it here. I'll start one here and I'll end it here. I'll start one here and end it here. So you'll see I'm choosing multiple chains because I'm in partial chain mode. So I'm always selecting the first and last entity in the chain. And this is a solid one, so that looks good there. So I'll select OK, and now in my spline curves dialog, I'm going to choose, I want to delete the original curves. I'm going to set a tolerance of 2 10,000ths, so make it kind of nice and accurate, and I'll say OK. And so now what I've got is this series of 4 boundaries on each edge, 2 of which in almost every case is made up of a pair of arcs. So what I want to do now is create some surfaces. So I'm going to patch these holes in. And there's a couple that I could do. I could do sweep since we've got basically a 4 boundary. The other thing I'm going to do here, I'm going to go to my quick masks and I'm going to select all wireframe. I'm going to right click just anywhere in the middle here. And from that menu, I'm going to choose the drop down for line width. And I'm going to choose the middle weight lines. I'm also going to right click again and choose middle weight as my drawing weight from now on. And that way I can see the lines a little bit better against the backdrop. For broadcast, I'm actually going to do this again. Grab all lines. Let's even go thicker. There we go. So we'll go almost all full weight. So now what I'm going to do is go to my surfaces tab, and I could choose sweep, and I could do a 2-rail sweep on one of the edges, but my favorite to do lately is net. So I'm just going to choose net, and basically you're going to walk around and choose the 4 boundaries of the surface, go with chains that go away from each other. Oh, at least 3 chains. You only selected 2 chains. Oh, I'm in partial chain mode. So what I need to do, sorry, I was in the wrong chain mode. I need to be in single. So I'm going to go single chain mode. That way I'm selecting each of these as an individual chain. And I'll select OK. And basically we can choose in our surface creation, if I look at it from the side so I can kind of see the curvature, you can see we've got along, across, and average. And sometimes if I unshade it and I play with a long or a cross or average, you can see a change in the shape, the surface shape. And you can look at it visually and decide for yourself which one creates the best quality surface. Sometimes it makes a difference. In this case, it doesn't seem to be making any difference at all. So I'll go back to along and I'll select apply or OK and create new operation. We stay in single mode. So you'll notice I just choose the 4 chains following around each other, and we're creating another surface here. So I'll do OK and new. Again, I'll pick my 4 chains, and you'll notice the chaining direction. I'm just going from one to the next, to the next, to the next, and I'm creating these little surface patches or fillet surfaces by using that net surface command. So this is the way that I would typically go about fixing a part like this. I would actually create surfaces from it. I would create surface patches, and okay, so our surface creation color is orange, which means these surfaces are backwards. Their normal is reversed. So what we're going to do is go into the surfaces tab here, and I'm going to go over to the normals option and click on change, and I'm going to reverse those normals. Now that wireframe was used to build my surfaces, but I don't really need it anymore. Once the surfaces are generated, I can simply select the wireframe and delete. Okay, so I use that wireframe to generate and fix those surfaces, but now I can get rid of that wireframe. I'm going to select all surfaces, and let's go and right click, and we'll move it to level 10. And that's the main level, so we can't, I think it's the main level. No, it's not. So we'll move it to 10. All right, and now if we look at 11, one of the things you'll see is that I chose this green color, color 10. Unfortunately, it's really close to the backside color. So what I'll do is select it all. I'm going to right click on the surface color, and let's pick something else. There we go. So on this back side, which is where we're going to sit up against the fixture, we've really only got one hole. Everything else looks pretty good. It's really just this guy right here that we need to get to. So I'm going to save it. We are in this blue color for creation. So wireframe, curve one edge. And you'll notice again, I did the curve one edge, but I got this huge giant curve because this is one big flat surface. Even though I didn't need the rest of it, I got it anyway. So that's a little piece, that one's fine. This guy needs to be broken. So break 2 pieces. I'm going to break that guy there. I'm going to grab those 2 pieces of wireframe, select them and delete them. So here's an interesting one. I don't want to delete all wireframe. I want to delete everything except this little bit of wireframe here. How can I do that easily? Well, there's a couple ways. I could go to this section of geometry, hold down Shift, and then click on it, and you'll notice it'll select that chain. And I could do the same thing, hold down Shift and select that chain, and then just press delete. That would certainly work. It's an easy way to grab all that geometry. But what if we had more than that? What if we had a whole bunch of extra stuff we needed to get rid of? What if we wanted to select just what we wanted to keep, not what we wanted to delete? Well, there's an interesting way to do that. So, for example, I want to save all surfaces plus this little bit of wireframe. I'm going to zoom in, I'm going to hold down Shift, and I'm going to click to select that wireframe. I'm going to go over to my Surfaces Quick Mask, and I'm going to press All Surfaces. So now I've selected all surfaces plus this right here. But what if I wanted to get rid of everything else? Besides that, that's what I actually wanted to keep. So now I can go up and I can use invert selection. So invert selection says whatever you've got selected, deselect it and select everything else instead. So I'll do invert selection. You'll notice it grabs those two other chains. I use invert selection all the time. So I grab just what I want to keep, invert select, and then I delete. So I just hit delete on the keyboard and blew that other stuff away. So over here, you'll notice I've got some interesting wireframe here. So I'm going to do spline from curves. I'm going to go partial chain mode. I'm going to grab those two chains. We'll get it set to delete curves. Okay. And I'm going to do surfaces. We're going to do a, I don't want offset, I want net. So I'm going to do a net surface. We're going to do single chain mode. Chain, 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 chain. And we're going to do change the normal, and then because I just don't need it anymore, I'm going to delete that wireframe. So I have fixed the holes in the model, but this is still the inside shell. So what I'm going to do, this is inner surfaces. Let's go ahead and copy these to level 50. All right, we're going to call those my fixture build surfaces. And I'm going to turn them off. And I'm going to do that. Let's just make sure this is all on. Move to the active level. Okay, so this is all on the inner surfaces. So this is outer surfaces. So I've got my inner and outer. It's all displayed, and I've fixed the holes in the model. But again, this is all just surfaces. So I'm going to select all of these surfaces. We'll make them green. I'll just pick all the same color. I'm going to make sure all the normals are facing the correct way, which they are. The last thing I'm going to do before I try to attempt to turn this into a solid, under the surfaces ribbon, oh, maybe not, sorry, under the home ribbon, we're going to go up to this little area that says check solid. We're going to go and use the test surface function. So analyze a surface model for self-intersections, bad surfaces with reverse normal directions, and allows you blank or unblank based surfaces. So this is what we use if we want to test the surfaces that we've got. We've also got check solid and solid properties. So if you're having problem with the solid that problems with the solids that you've imported, you can analyze those solids using this check solid function. So I'm going to do test surface. I'm going to use the select function here. It says select surfaces. I'm going to select them all, perform end selection, and we're going to look at normals, everything else. We're going to say show me small surfaces, anything with a surface area size less than 4/10. There are 0 small surfaces. No problem was detected. 392 out of 540 are trimmed. 0 bad surfaces found. A bad surface is a surface whose normal suddenly reverses direction. Using dynamic analyze to investigate further. Everything was good. So I didn't get anything reported that was bad. So like I said, I fixed the holes in the model. The last thing to try here, I'm going to save it. We're going to go to solids, and we're going to try solids from surfaces. So select one or more surfaces. I'm going to use select all surfaces. I'm going to tell it, I'm going to do end selection here. Over here we've got an option, original surfaces, keep or blank or delete. I'll say delete. Create curves on open edges. What this is going to do is if there's a problem, if there's some kind of unstitchable area in my solid that I'm creating, it's going to create geometry at that problem area. So at least it tells me where to go look to try and fix my problem. So I'll say OK, and you'll notice in the lower left-hand corner it says it's processing. So it's going to take a few minutes or seconds, go through and try to attempt to build me a solid. Now, if there was a problem, it'll usually report that there was a problem. Open shell body created, could not do something, blah, blah, blah. In this case, it looks like it built me a solid that works. I'm going to move it to level 20. Just because I want to see what's left over. I'm going to select level 40 and then select turn off all levels. So it looks like hard to say if it created just some extra stuff there or not. So if I select it, if I go to the home tab here and I do check solid, it does say there's some problems. Total errors 411. Maximum number of errors to report 10. So if I do 1,000, apply, you can see I've got my 411 errors. So it's giving me errors probably about the tangencies of edges together, all that kind of stuff. So I've got all kinds of problems, 411 of them to be exact, when I tried to generate this solid. So at least we know there's some problems. So what can we do? Well, let's go to model prep. First thing I'm going to do is save the file. Anytime you do a big operation like that, it's a good idea to save. First thing I'm going to do is go save it, and then I'm going to go and choose automatically repairs imported bodies by improving the accuracy of edges. So we can try optimize. We can also try simplify solid. I don't think this is a candidate for simplify. If we went to this model and we saw this flat face here, and there was like a line right in the middle where the face was split for no reason, or we went to the edge of a hole and you noticed that the hole was split in two, so there were two semi-circular faces that are tangent to each other. That's the kind of thing that Simplify Solid will help to fix. But what we're going to try is optimize. Not simplify, we're going to try optimize. So I'm going to choose the whole solid, select OK. It tells me right away, cannot be performed on sheet body solids. So it was only able to create what we call a sheet body. We can try Simplify Solid. Now, still says it's a sheet body. So, one of the things that we should note when we tried to generate this whole thing before, this is kind of the place we got tripped up. We've got 2, 3, 4. So here's our 12 entities. Basically, when we tried to generate this solid, we told it to create edge curves on open edges. And what it did for us is it says, now the place that I'm having trouble when I created this solid is right here. It's these edges right here. So what I'm going to do is I'm going to do undo a couple of times till we get back to just surfaces. So I'll do home, screen statistics. We've just got surfaces. And if I grab this guy and I unshade, based on the shape of the UV curves right here, I can already tell these little guys in here are going to give us problems when we try to go generate this into one big happy solid. So what can we do? Well, I'm going to select that guy, and that guy, and I'm going to delete them. So this is probably part of the deal right here, is where does this edge end and where does this edge start? It's probably just having a tough time generating it. This is another deal right here where you can tell we've got what are basically some kind of overlapping edges. It's just kind of an ugly area on the model. You can see right down through here, there's this area where there's just this really weird, ugly kind of overlap. So if I delete that guy, and this is where we can really run into some problems with poor modeling. So whatever surface modeler was being used is having a problem with the height of this rib here, the height of this here. Yeah, exactly. Looks like the modeler did a poor job. Yep. And you've got, this may be at a like slightly different angle than this face here. It's really hard to say. But, you've got some model edges over here that seem to meet okay, but then these kind of really ugly model edges right here. So we're going to need to kind of rebuild those surfaces. So wireframe, and I'm going to do break 2 pieces. Break it there. So sometimes we run into these issues. Oop. Oh, did I accidentally delete those? I didn't want to delete those. Okay, go save, save, save. All right. All right. So in this little area here, we go into surfaces, and I am again going to choose net. And the problem with net is that we're really supposed to be restricted to choosing 4 edges. So what I'm going to do is choose single, and I'm going to choose this edge here. I'm going to choose this edge here, so they're both pointing in the same direction. And I'm going to choose this edge here. That's 3 edges. For my 4th edge, I'm going to choose the option here for point. And I'm going to go choose that point as my 4th chain. And I'll say OK here, and you can see there's a lot of twist in that surface. So let me try this. I think that's only with coons. Let me try again with net. And we're going to do single. Let's go away. And let's choose those 3. That's what it was. Okay, so now with the new net, you don't have to choose that point. You just have to choose the chains in the right order. So we did that one. We can also try across, average, along, see if that makes any difference. I don't really see that much of a difference there. So some of the question that we have to answer when we start to build a model or we start to try and make a solid is how close is close enough? How accurate do we need to be? I can see that down here we've got this little edge that overlaps from this surface down here. So one of the things that we can try is trimming the corner of this surface to try and have it interfere less. So I'm going to go into wireframe. I'm going to do curve 1 edge. I'm going to choose this bottom edge curve here. And then what I'm going to do, I'm going to select that edge curve, and I'm going to use the project command. So I'll do project, and it says, what do you want to project it to? I want to project it to a surface. So I'm going to project it to this surface here. I'll say end selection, and I'll choose over here, I want normal. So I'm going to do normal, and I'm going to tell it I want to move it. And so what I'm doing is I'm projecting that edge here onto this surface here. And so the reason that I'm doing that, I do have another little piece here. So I've got this piece here, I've got this piece here. Some of it didn't translate onto the edge perfectly. It's a good chance for blend. So I'm going to go to wireframe, spline, blended spline, and I'll create a blended spline between those two edges. I'm going to go in here and choose spline from curves. Let's do unselect, full chain, and grab the whole thing. Say OK. And now I'm going to do surfaces, trim to curves. That's the one I want to choose. Select the surfaces, press enter. Select my chain. I'll select my chain and press OK. Indicate the area to keep by selecting the surface to be trimmed. So I click on the surface, and now I get this little dynamic arrow, and I want to drag it to the side of the surface I want to keep, which is down over here. And we'll make sure it's set to normal. And what I'm doing is I'm trimming, at least I'm attempting to trim the edge of that surface. Maximum distance from the trimming curve, extend to edge, and we say OK. And so what I'm attempting to do there is clean up the interference between these edges. So we've rebuilt this surface over here. We know that this one over here is a problem. So let's go ahead and fix that. So one edge, one edge, one edge. We're going to do break two pieces. And we're going to get rid of that piece. And then we're going to do surfaces, net, single chain mode, and we need to change that guy, and kind of last one here. One edge. So this may or may not fix it. We may not be able to get a solid that will stitch using the geometry that we're given. Sometimes it just doesn't happen. The other thing that we didn't try, however, we did not try, and we can try to open up our tolerance. So I think we used a 5 thou stitching tolerance. And so I don't know if these guys over here need to be trimmed. But we can try just opening up the tolerance and see what that gives us. So let me save this. Let me pull up outside surfaces. I'm going to grab all wireframe and delete it. So now all surfaces are visible. Save it. And we'll do solid from surfaces. I'm going to grab all surfaces. I'm going to set my tolerance to 10 thou. And we'll say OK. So it's processing 540 surfaces. and we're on level 40, so I'm going to do turn off all levels. I'm going to select that guy and do invert selection, and then we'll do Alt-E. Oh. So if I right click and I move this to 15, and then I do level 40 all off, and I do fit screen, you notice we don't see anything. It says there's one entity on level 40, but if I go home and I do statistics, I see I've got one tool. So if I go to level 15 and we go to isometric and I do F4 for analyze entity, it tells me we had success. I now have a closed solid body, and I can do check solid. It does tell me I have 414 total errors, but I have a closed solid body nonetheless. So at least I can work with this as a single unit for toolpathing or whatever purposes. So we've got this guy for our solid, and we've still got our interior surfaces that are going to be the what we can think of as the surfaces on the outside of our fixture. So if I turn off level 15, this is what we've got for the outside of our fixture. So it looks like we've got, this surface and this surface are likely to be mutually perpendicular. I'm guessing something like this surface and this surface are probably mutually perpendicular. So because of that, we can probably create some wireframe out in 3D space that we can use to work with if we're building a surface. So for example, I can go into wireframe, curve on one edge, and I'll use the edge of this surface here and the edge of that surface there. Because I did that because I figured I could probably get two lines off of those surfaces. So if I analyze those, F4 on the keyboard, line and line. So one of the things I always make sure I do when I'm analyzing stuff is I turn up my precision. So I turn up my precision to know how close stuff really is when I'm working with it. So with these two lines here, since they are likely to be on the same plane as this surface here, even though if we look in 3D space, if we look at this in the top view, it's not lined up to anything. If I look in the front view, it's not lined up. If I look in the right side, it's not lined up. Okay, so because of that, if I want to work on the model, I need to create a plane that's local to the model. So I'm going to go over here and I'm going to go to my planes menu, and I'm going to click this little drop down here, and I'll choose from geometry, and I'm going to choose these two lines. And what I get is this gnomon, this coordinate system in 3D space that has 8 possible orientations. So I can click basically next plane until this is oriented basically either the way it sits in the real world or the way it sits how I want to work on the model. I'll choose this guy right here. It's just like this, and I'll select OK. And so now what I've got is this plane that's sitting out in the middle of 3D space, but it's relative to the model. It's oriented to the model. So I can tell it, hey, I want to set this as my WCS tool and construction plane. And I'm just going to say fixture build. So this is now my origin, and it's now my active WCS, which means if I choose top, we're looking at this from the top view of the part. If I choose front, we're viewing this from the front view of the part. If I choose right side, you'll notice it's now lined up to these features on the model. And so what I can do now is say use some features of the part to start designing what this thing is going to look like as a fixture. So we're going to say this plane right here is now Z0. That's my origin. XYZ 0 point. And so if I right click and I choose my Z depth, and I go and I choose endpoint, and I pick the endpoint of this bottom surface, and I right click again, we can now see that that's 8.5 inches below this point up here. So I'm going to say I want to go minus 12. I'm also going to right click and set this to 2D mode. And now I'm going to look at this in the top view. Okay, that's looking good. So what I'll do here is I'm going to say create curve on one edge. And I'm going to create a curve on that edge. And I'm going to go and I'm going to create a curve on that edge. And I'm going to create a curve on this edge. And I don't know if you can see, but if I look at this in the front view, no, if I look at this in the right view, this edge is tilted. But because I'm in a flat drawing mode, I was able to choose this bottom edge here, and it created a flat 2D representation at Z minus 12. And so over here, I'm going to click on this edge here and this edge here. Oh, I was going to see if it would create a point for me. Apparently not. So I'm going to have to create one here and here. There we go. So now I'll look at this in the top view. Okay. All right. So what I'll do is I'll choose this point. Oh, I'll do that. Line endpoints. Choose there and there. So let me see where this line is. I'm going to do F4. So the Y value is almost 9 inches. Let's make it 10. So I'll make it 10. I'll make it 10 there. I'm going to grab this guy here. And let's just do this. Let's go top. So the part of my problem is my plane origin right now is coming from the intersection point of these two guys right here. So I'm going to grab my WCS. I'm going to choose my origin point, and I'm going to choose the midpoint of that line. So I've just reselected the new origin. And then that way, when I look at this line and I look at this line, what I'm hoping is they will be symmetrical. So 4.x is 7.59375, and if I do my next entity, 7.59375. So I'm exactly in the middle. So what I'll do here is I'm going to do X 9. So we're going to do positive 9 there, and we're going to do minus 9 here. And I'm going to go to the top view, and I'm going to grab that line, and we'll do minus 2 and minus X2 and Y. And now what I can do is I can trim all these guys together. And maybe this is too close down here, you know. This guy right here is 10, so we're going to go I'm going to go 40. I'll tell you why in a minute. Maybe not. Maybe we'll do 30. Grab that guy. Alright, so I'm moving these lines around by just selecting them and analyzing them. And what I'm doing down here make sure I'm on only wireframe. So I'll select that wireframe down there and delete it. So we're going to say this is a piece of tooling plate, and we're using this to kind of construct our solid, basically, you know, our fixture, how this thing is going to fit on the fixture. And normally what I would start to do here now is figure out what parts of these surfaces am I incorporating into the physical solid model that I'm going to be building for my fixture. Because I may use some of those actual surfaces themselves, but typically what I'm going to do is take some wireframe, project it down, build a flat profile, extrude it, and then start chopping away some features of it to build my own solid so that I can control all the features. Because, you know, I may not want to put a whole lot of detail in this. Like, would I, on my vacuum fixture, would I machine in all of these fillet surfaces? Probably not. I would probably use like these guys right here, and I would probably machine support by running you know, a router bit around here and cutting these with a sharp edge. And then that way I've got this surface here that's supporting the part, and I've got some little ribs that are on the center line here that are supporting the part, but I don't have to worry about putting in full detail on the fixture model that I'm making for holding this in a vacuum fixture. So, you know, guys, lots more stuff, of course, to go through when it comes to creating geometry, organizing geometry, working with surfaces, fixing surfaces, 5-axis tool pathing, the whole 9 yards. Now that we've essentially got, let me turn on all the geometry. So we've got a solid model sitting in 3D space. This is essentially how it's going to be oriented relative to this fixture plate that we're designing. I mean, obviously we're going to have to make the actual physical fixture solid that would go on the part. But I guess the question is, do we want to just put a WCS on it here in 3D space and cut on it, or do we want to move it all back to the system origin? Personally, I like moving it back to the system origin. So what I'll do is I'll show you guys moving this set of geometry back to the origin. Then I think we're going to wrap it up for tonight. It's getting a little late. It's Sunday, so I got to get up early, and my wife's starting to text me saying, "Hey, how long are you going to be? Blah blah blah." So anyway, guys, let's go ahead and look at moving it. So we can easily build work coordinate systems, basically a work offset location. We can build it and we can orient it pretty much anywhere we want. The question is, when do we change it? In our case, what we really want to do for a 5-axis gantry router is we want to take all this stuff and we want to move it back to whatever's going to be our system origin. But what I like to do is create a copy of the top. System top view, I create a copy of it so that I can actually move the origin around and change it when I need to. So what I will typically do, we were having a discussion about this relative to WCS or create relative view. So if I go top and I say create relative, this can get us into trouble. Duplicate does not. Duplicate creates a plane that is not tied back to the original. So I can go to top and say I want a duplicate plane. And now I would typically say this is going to be op10. So typically in manufacturing, we have like op10, op20, op30, and so on. So every 10, units or whatever, there's a new operation in manufacturing: 10, 20, 30, 40, 50, 60. So typically we're going to start out with our very first operation. That's going to be op10. And in this case, op10 is equal to top. If you look here, the icon orientation didn't change at all, but we've just made a copy of top, and that's what we want to use to match up with. So in this case, I've got all this geometry. Underneath my levels, I've turned it all on. Now what I'm going to do is I'm going to select it. So I'm going to unzoom, I'm going to left click, hold, and drag, and I'm going to drag out a window. And then I'm going to choose dynamic. And now you notice right now it automatically shows me that I'm in 2D mode because I'm only getting a gnomon that's got X and Y. So I need to right click and choose 3D, which now changes my gnomon and pops it up. Underneath advanced, I make sure set to geometry when placed is turned off, because I want to control what mode I'm in. Am I orienting my gnomon, or am I moving my geometry? I don't want to move. I don't want to change between modes till I'm ready. So I'm going to click to place it. I'm going to slightly rotate it around, and each part of this gnomon, whether it's the little spindle on Z, the spindle on X, the spindle on Y, or it's the cone, or it's the little piece of arc that connects them. Each one of these is a separate button. So when you press on these, it's going to choose how it orients to the model. What I like to do is use this yellow pane. The yellow pane here is the X, Y plane selection button. So I'm going to choose, and you notice if I'm here in between Z and Y, nothing highlights in yellow. If I'm in between Z and X, nothing highlights. If I'm in between X and Y, it turns into a little yellow window. I'm going to click it. Now it says pick the entity to align to. I'm going to click to this top face here and then click it. Now my gnomon is oriented flat to my model. I've changed the orientation in space so that the gnomon itself is flat to the model. The last thing I want to do is place it. So I'm going to click on the little origin point back here, left click it, and now I'm going to drag it till it's at the midpoint of this solid edge. One of the reasons I get an advantage if I'm working with solids is I can recognize the points that are on the edges, like endpoints and midpoints. I don't get that with surfaces. So I either have to have wireframe geometry or solid geometry to be able to auto cursor pick those points up. Now that I've oriented my gnomon to the part, I am going to choose this little button to switch to geometry manipulation mode. And now what I'm going to do, over here we're going to select method move, and for my axes I am going to click on world. And what I just did is I just completely reoriented my model so that the model is now reoriented to my world axes. And then under origin, I'm going to click on world. So in 2 steps, after I oriented the gnomon to the part, I just moved the part back to the world origin and I oriented the part to the world axes. I'll select OK. I'm going to go to my planes. I'm going to choose op 10 and make it equals. And now I'm going to choose isometric and see how the part is oriented. So if I'm looking down from the top view on my machine and my part is oriented correctly, I'm good. I'm done. But if it's not, now we need to orient it relative to how it's sitting in the real world. So let's do this. So I've selected that to be where my Z depth is. I'm going to look at this in the top view, and we're going to go to wireframe. I'm going to hold down shift and click on that point, and now I'll get my little relative points here. So I'll choose OK, and diameter 23.75. So what I'm going to do is grab all this geometry and I'm going to rotate it. Move it 90 degrees. And now in 3D mode, I've got this hole that I'm going to make the origin point for my model. So I'm going to select everything and I'm going to say move to origin, and I'm going to move from the center of that circle. And now when I look at my model, this is how it's sitting in 3D space. So if I look at it from the top view, the origin is in the lower left hand corner. It's at the bottom of my fixture plate, and this is how my part is sitting in 3D space. So if I went and I analyzed my fixture and I measured it, with a dial indicator or something else, one of the tricks you can do is put like a 2-inch or 1-inch travel dial indicator inside a tool holder and set the length with the dial at 0, set the length of it to a known value, 5 inches, 5.5, 6, 7, 8 inches. So you've got a known tool length. And then you just go and use some drill tool points with a stop at a point, and you can measure how far the model actually is in 3D space from where you think it's at in 3D space. And the point is, if this geometry is not right, move it. So if we went and we analyzed this in the real world and we determined that this model here needed to move, right, we might say, well, I'm going to look at this from the front view. I'm going to select this geometry, and I'm going to go into translate, and I'm going to move this in X minus, 42.5 thousandths in X, and in Y it's off just a little bit here. It's off, 4 thou. So I'm going to move it minus 4 thou. So when we get done and I do clear colors, this model is now sitting exactly in space in Mastercam where it is in space in the real world, so that when I go to put tool paths on it, everything's going to line up and be where it's supposed to be. So that's part of what we need to get to with setting up setting up everything inside Mastercam, is that your model geometry in 3D space actually matches your fixture in 3D space in the real world. And at this point, you can now go and start creating wireframe geometry on the part, create surfaces and solids and all that for designing a fixture. We can certainly do that later on. It's just getting a little late on a Sunday, so I think we're going to wrap it up here pretty quick. And then we'll get into building a fixture for this thing probably next time. So, all right, guys. Well, I hope it was useful. And I know sometimes that it seems like we just talk about some functions and how I do things, and then hours go by. But sometimes it's just useful to be able to ask questions to someone, because it's hard to get to the next step if you can't have the current step explained, right? Like if you don't have anybody to say, well, but why are you doing that, or what's really the point of that, or what's the whole reason you're doing this, and then you have somebody actually explain that, then you can kind of move on to the next step. So, all right, Thomas, guys, Dan, John Ford, glad you guys could make it. So I guess we're gonna stop streaming. So thanks for joining me, guys. Yeah, you're welcome, Tom. All right, guys. So we're going to wrap up the stream. Thanks for joining me, everybody. And, next time we've talked about a little bit about using the WCS, planes, levels, took this part, made a plane on the part, created some geometry relative to the part, using the orientation of the part itself, and then we created this rectangle, which is essentially the fixture plate underneath the part. We could then move that around if we needed to, and we're in the process of designing a fixture for the part based on the part geometry itself. So really, we start with the part itself, analyze what do we got, fix it if necessary, and then we start, moving it in position and using geometry tools to start building lines and arcs and planes and rectangles, and then cylinders, and we start extruding those things to start building the actual fixture that we're going to design. So probably the next time we get into this, we'll look at taking the edges of this part, projecting them down to build a silhouette boundary, and then extruding that up, designing some blocks to actually make a fixture from this thing. And then how do we machine that? How do we do some surfacing toolpaths, some like OptiRough, some of that kind of stuff to take a solid block of like Wren shape or foam or some other type of fixturing material, wood maybe, and start cutting it out so that we can start actually building a 3D vacuum fixture. So, all right, so we'll get into that next time. Thanks everybody. I'm going to go ahead and end the stream. Thanks everyone for joining, and I'll catch up with you guys next time. Stay safe, everybody. Hope everybody gets a chance to get their vaccine. I just went and got my first one. Let's keep the world safe, and go from there. Hope everybody's having a better time, and good luck, everybody. All right, thanks everybody. See you guys later. Bye-bye.